Okay, we are going to look at angled launch, specifically finding the initial velocity. All the ones I've done up to this point, we have the initial velocity, we have the angle. Makes the problem pretty easy to solve. Finding V0's one of the trickier ones, especially if it doesn't end and start at the same height. So let's give this one a try. So I have a field goal kicker who wants to kick a ball at 40 degrees through the uprights that are 3 meters high and 20 meters away. And I want to know what's the minimum speed they can kick it and get the field goal, assuming they kick it straight, of course, and no air resistance. So let's set this problem up. So that ball is moving in 2 dimensions, both the x and y. Therefore, I have to list my variables. Okay? And as usual, in a 2D motion problem, the time is going to be the same. All right. The next thing I have is I have an angled, let's do projectile motion first. It's projectile motion because it's moving in the x direction and it's in free fall in the y. So my acceleration is 0 meters per second squared and negative 9.8 meters per second squared in the y direction. When I have 0, the initial and final velocities are the same. And when I have a 0 acceleration, I'm using the equation x equals x naught plus v naught xt plus the 1/2 at squared term goes away. All right. And remember, we're going to keep these two sides separate. All right. It's also angled launch, so that means I need to resolve this into components. So I got to find the v0 x and the v0 y. So this is going to be v0 cosine of 40. This one's going to be v0 sine of 40. Now I'd like to point out to you, even though we don't know this v0, we still resolve it. We still break it into those components. All right, let's bring that over here. So I have v0 cosine of 40 and v0 sine of 40. All right. The next thing I have to do is I have to choose my coordinate system. So here we go. Starting point, ending point. So I choose the leftmost place as x equals 0, and I choose the lower of the 2 points as y equals 0. So it starts at 0, 0. It ends at a position of 20 meters and a height of 3 meters. Okay. So now I have my variables listed. I have an angled launch. It's not a max height problem. It's not a y0 equals y problem. So this is about all I can do. So the rest of it is all about solving for v0. So let's see what happens when we try it this way. So in this direction, I try it and I cross out anything that's 0. So I have x is equal to v0 cosine 40 times t. Oops, times t. All right, so now I know x, but I don't know v0 and t, so I have 2 unknowns there. So maybe I can find time in the y direction. So I say, well, I'd like to find time in the y direction, so I pick an equation without the other variable I don't know, and that's equation 2, so same equation, so y equals y0 plus v0 yt plus 1/2 ayt squared, crossing out that 0, and start substituting in. I get y is equal to v0 sine of 40 times t plus 1/2 ayt squared. Again, I have 2 unknowns, v0 and t. So I can solve this though, because I have 2 unknowns and 2 equations. So the rest is going to be algebra. So let's get after this. So what I'm going to do first is I'm going to solve for time here. Okay? So I get x divided by v0 cosine 40. I'm solving for time because whenever you have a system of 2 equations and there's no easy way to do it, what you do is you solve for the variable you don't want first because you're going to substitute it in and get rid of that variable in your second equation. So let's go ahead and do that here. So I now have y is equal to v0 sine of 40 times time, which I get from over here. So it's x divided by v0 cosine of 40 plus 1/2 ay times t squared. So this thing's squared. X divided by v0 cosine of 40 squared. All right. All I got to do is solve for v0. All right. So it looks a little difficult, but there's a silver lining here. These v0s cancel for you. So it's really just this v0 down here, buried in all of those terms that I got to single it out. Now, there is one little trick we can use here. Okay? we can work smarter, not harder, and that means we use our calculator. So let's get this set up in a way that our calculators will work. Now, if you have the older TI, you're going to have it 0 equals. If you have one of the new TI colors, you can leave it in this form. I'm going to show it with the 0 equals because you can use that with the color. It's just 0 on one side. Okay, so I'm going to move my y over. So now I have 0 is equal to negative y, which was negative, and then 3. And then I have plus x, which was 20. And then I have sine of 40 divided by cosine of 40. Sine over cosine, tangent. So I have the tangent of 40 plus a, which is negative 9.8, times a half, so that's negative 4.9, times all of this squared. So I have 20 divided by v naught cosine of 40 quantity squared. All right, let's flip over to our calculators. All right, let's use this solver. So I have my equation, and I want to use the solver on my calculator to solve it. So I'm going to need to either follow the steps here for how to use it on a TI-84 Plus, or the steps here if I have the color version. All right, so I'm going to first show you on the TI-84 Plus, then I'm going to show you on the color. All right, so first thing we got to do is we got to open up Solver. So in order to do that, we got to go under Math and Solver. So Math, and that's all the way at the bottom, so if you just press up, it'll take you right to the bottom. Choose Solver. And if yours doesn't pop up 0 equals, maybe you have something in there already. Your screen might look like this. Just press up until you see 0 equals. It's at this point you're going to enter your equation and press enter. Okay, so I'm going to hit clear since there's something in there. So negative 3 plus 20 tan 40. Now make sure you're in degree mode if you're using things like degrees here. Minus 4.9 times 20 squared divided by v squared, which I'm just going to call it x. Well, let's call it v, what the hey. Alpha v, you could call it x though, squared times the cosine of 40 squared. Okay, so I've typed that into my calculator. I just press enter now, and it gives me v equals 0. Well, that's not my answer. I have to put a guess in. And so I'm just going to give this a guess of 10. I just need a reasonable number for the problem I'm doing. And then I'm going to hit alpha down to this part now. I have to choose a guess. I have to choose my bounds. And then I'm going to hit alpha solve. If you want to mess with the bounds, so like for instance, I'm going to want a positive answer. So I might put 0 in. And so I want a number that's between 0 and 1 times 10 to the 99th, which is pretty darn big. So I will hit alpha solve, and you have to be kind of highlighted over that variable that you want it to solve. And so you hit alpha solve, and it'll take you to the nearest solution. So here my solution is 15.6. All right, let's see how this looks a little different on the TI color. All right, so here we are in the TI color. We're going to be doing kind of the same process. All right, so I have math, got to go down to solver, and we're going to type in the left side of the equation in equation 1 and the right side in equation 2, so 0. And then in the right side of my equation, I'm going to type in all of that stuff up here. Now, if you had numbers on the left side, the TI color doesn't mind that. The regular does care. It has to have its 0 equals. All right, so let's type in that equation again. So negative 3 plus 20 tan 40 minus 4.9 times 20 squared divided by, and we'll do x this time, x squared times the cosine of 40 squared. Make sure we typed all that in right. Make sure I'm in degree mode up there at the top. And now here, we're going to be pressing OK. Now, OK is right above the graph button, so really we just push the graph button. Okay. Now, X has been stored as 45.5. That's not my answer. Again, I have to choose a guess. So I might choose 10 for my guess. Again, I can mess with the bounds just the same way. So here I will get a positive number. Highlight over the variable you want to solve for and click alpha solve. It'll find the nearest solution. Okay, that's kind of the trick here. If you have 2 solutions or 3 solutions or an infinite number of solutions, maybe you're using a sine function or something like that, what you're going to want to do is you're going to want to choose a guess that's going to be closer to the answer you want than the answers you don't want. It'll find the closest answer. All right, that's how you use the solver. Just like that. So now we have our answer. Solver has done it for us. So if we want to write that down, we'll just write solver ... And that will tell me what you did to get that V0 value. And your V0 value on the solver, again, was 15.6 meters per second. The end.